All right, we're recording. Okay, some things I'm going to put as far as understood symbols. Okay, so in general, I like to give these quick in-class assignments before you leave. But when you type on a keyboard, you can't get all the symbols that we're used to writing in a normal math sense. So I'm going to type on the chat, so you can look at the chat the way we do some things. Okay, for exponents is usually the so-called up caret, which is above the 6. So let's say I'll write something like this, 2 to the 4th power. Okay, so you can see how I do that. Okay, so that's usually above the 6, right? So here's how you would type, let's say 7 squared. 7 squared, okay? So for an exponent, it's the up caret, like so. The 4 basic arithmetic operations, so they're already on the keyboard, so you should be able to get a plus, minus. For multiplication, it's the asterisk, which is above the 8, and divide, okay? So that's plus, minus, times, and divide. Plus and minus are pretty straightforward. For multiplication, it's the asterisk, which is above the 8, and a slash for division. Square root, we normally just type squirt. So square root of x, you type squirt x. So if you look at the chat, that's how you would type square root. We might have cube root once in a while. For cube root, just literally type cube root. So cube root 27, like that, cube root of 27. Okay. The big one's mainly for the exponents. So you see the up caret for exponents. Okay, so yeah, so let's say quite often we have to have something squared, right? So this is x squared. Oops, supposed to do that for everyone. Okay, so that's x squared plus, minus, times, divide, right? Squirt for square root of x, something like that. Okay, and yeah, I think those are the main ones. Okay, so use those as necessary because, when you type it, it's hard to get those. So we'll use that as our convention. So you might need that for today, if I give you one today or any other time, okay? All right, so let's go ahead and begin. So share the screen. Get that. Justin Bierman, I got you. Okay, so look at the calendar. We are here. So it's supposed to do 1.5, 1.6. I was done with 1.5, so I'm a little bit ahead. I'll go on to 1.6. Okay, and we're looking for every Thursday pretty much is a quiz or exam. So a quiz, just like last week's quiz, very similar. But then the Thursday after that will be our first test. Okay, so a reminder, the tests will cover chapters 1 and 2. So next Thursday, which is going to be the what? February the 4th. Okay, so you turn in all the homework then. I don't need the homework day by day or week by week, just test by test. So you turn in all of this stuff. I end up doing quite a bit of the problems anyway, as you know. I do anywhere from 1/4 to 1/2 of all the homework, so that's less homework you have to do. So you must turn in the homework. I have a 70% requirement for homework. So if you don't turn in at least 70% of the homework, I don't grade your test. Okay? So that's the way I do things. Okay, so I'll get started with 1.6. It's pretty much a review of straight lines and how to do lines. Okay, so hopefully this is review. So that being the case, I'm going to go fairly quickly through lines because you've seen all this before, hopefully many times, algebra 1, algebra 2, and so forth. Okay, so equations of lines on page 42. Okay, so first on page 43, okay, we have the formula for slope. If you're given 2 points, the formula for slope m y2 minus y1 divided by x2 minus x1. You can put it on your cheat sheet if you wish or not. Okay. You may not have seen this before. Okay. The triangle x, we say delta x, D-E-L-T-A. So this is sometimes called delta x and delta y. Delta means change. Okay, so change in x, change in y. So delta x, that triangle x, that's a Greek letter delta. Change in x, change in y. Delta y, y2 minus y1. In case you've never seen that before, delta stands for change. Change, I'm going to write it directly in my book. Okay, so delta y, change in y. Delta x, change in x. Okay. So you can think of m as delta y over delta x sometimes. So I'll put that over here also. Delta y over delta x. Okay. Change in y divided by change in x. Okay. So that's on page 43. So that's slope. I'm sure you've seen that before. Okay, and then comparison of slopes on page 44. Again, I'm going fairly rapidly because you've seen this before. Okay, so if you look at line number 1, that's considered a positive slope, okay, because as you move from left to right, it's going up. Line 2 is also a positive slope, but not a steep. So that's going to be a smaller slope. Line 3 has a negative slope. It's going down. Okay, so that was on page 44. Page 45. Figure 5. Okay, so you can see a larger positive slope, and a negative slope. Figure 6. You have a horizontal line, line 1, that has a slope of 0. Line 2 is a vertical line that has undefined slope. Okay? Undefined slope because when you try to use the formula, you end up dividing by 0. Okay? So line 1 again, has a slope of 0. Line 2 we say is undefined. Sorry, I can't write it because I'm holding up the book. Okay, but I think you've heard this before. Undefined slope, line 2, in case you want to write that down. Okay, page 46. Horizontal line. So number 1, the slope of a horizontal line is 0. Slope is not defined or undefined for vertical lines. Okay. All right, they've got figure 7 here. They show you various lines that go through the same point with different slopes. Okay, so figure 7, you see slope of 4, slope of 1. So slope of 4 is steeper. Slope of 1/4 is less steep, but still positive. Then they give you a slope of 0. And slope of negative 1/4 is negative, but not so steep. Then slope of negative 1, negative but steeper. And slope of negative 4, which is steeper still and negative. Okay, so we use M for slope, right? All right, then we have the point slope form. Again, you've seen that before. If you want to put that on your formula sheet, you may. We'll be using this quite a bit. Okay, so you have a given point M as point x1, y1. Formula is y minus y1 equals m times x minus x1. Again, that should not be new to anybody. Okay, y minus y1 equals m times x minus x1. So we'll be using that from time to time. Okay, then page 48, horizontal and vertical lines. A quick reminder. The equation of a horizontal line is y equals some number, like y equals b. So to give you the point A, B, the horizontal line is just y equals b. If you have a vertical line that passes through A, B, it's just x equals a constant. Okay? So there is a vertical line, a horizontal line. So look at figure 12. Y equals a number, y equals b, horizontal line. X equals a, vertical line. Okay? So those are the equations of horizontal and vertical lines. Okay, Y-intercept form, I'm sure you've seen that before. Probably most familiar. Y equals mx plus b. Okay, slope is m, y-intercept b. Okay, we're not going to look at this one very much. It's not that useful. It's there, but we're not going to worry about that. So you want to know point slope, slope intercept, y equals mx plus b. Point slope, y minus y1 equals m times x minus x1. It's on page 49. You're welcome to put that in your formula sheet if you wish. And then before we get started, finally, parallel and perpendicular lines. Okay, so on page 50, here are some lines that are parallel. What seems to be true about them? They have the same slope, same steepness. Okay, so lines are parallel if they have the same slope. M1 is equal to M2. Perpendicular is a little bit tougher. We won't prove it, but we'll just state it. Again, you've seen this before, hopefully. Two lines are perpendicular if M1 is equal to -1 divided by M2. These are sometimes called negative reciprocals, and I'll write that down. Negative reciprocals. Okay, now you've heard of reciprocal, right? Just flip the fraction. Negative reciprocal means flip it and change the sign. -1 divided by M2. Okay? So two lines are perpendicular if M1 is -1 divided by M2. They're what's called negative reciprocals of each other. Okay, so we'll be doing some of each of these kinds of problems right now. All right, so we'll go ahead and get started. So we're doing 1.6, and I'm a little bit ahead. I wasn't supposed to start 1.6 until tomorrow, so that's okay. The assignment is 1 to 35 off. As usual, I'll show you how to do some problems, and then you can do the surrounding problems that are there. Okay, so 1.6, page 52. Okay, 1 to 35. Again, I'll show you all the problems in case you never plan on getting to buy the book. So raise it up. So there's some problems and some more. And then problem 7, 9. Okay, yeah, that should be 9, I think. Yeah, there. Okay, next page. 11. 13. 15, 17. And let's see, how high do we have to go again? 35. So let's see. 19 and 21 and 23, I think. Yeah. All there. And 25. And 27 and 29. Okay, and then let's see, 33 and 35 must be on the next page. And there we go. Okay, now the directions sometimes ask for this ax plus by plus c equals 0. I'm not going to do that. It's not necessary. Okay, let's just go for y equals mx plus b in our answers. Okay, so I'm going to put the book down because it's heavy. So, as usual, let me get started and show you how to do some of these problems. Okay, 1 to 35 odd. All right, so here we go. So 1.6, page 52. Let's see, what day is today? The 26th. Okay, don't worry if you can't see what I'm writing. I'll have to write and then switch over. Okay, compute the slope of the line passing through the given 2 points. Okay, so you just get 2 points, find the slope. So 1 and 3 are similar. I think I only have to show you one of those. I'll do 1b, perhaps. 1b. 2, -5, and 4, 1. find the slope. So x1, y1, x2, y2. Formula is y2 minus y1 divided by x2 minus x1, which I'm sure you've seen before. Okay, so 1 minus a negative 5 divided by 4 minus 2. So 1 minus a minus 5 is 1 plus 5, 6, divided by 2. So the answer is 3. And let me raise it up for focusing purposes. And you've all seen that before. So hopefully no big deal. Okay, so that's how you do 1, A, B, C, and 3. Shouldn't be too bad. Okay, 5. Refer to figure 2 on page 43. So unfortunately, I have to turn back the page. Find delta x, delta y, and m equals delta y over delta x. What does that mean? Okay, so let me write all that down. So they want delta x, delta y, and m equals delta y over delta x. Okay, so you have to go back to page 43 for that. So I better show you page 43 for the benefit of those of you that aren't getting the book. So what do they want? Figure 2 on page 43. Okay, so there we are. So it goes 5, 10, 15, 20, 25, 30, and upward goes 15, 30, 45, 60, and so on. Okay, so this is the figure that we want, page 43. Okay, so they're all pretty similar, I guess. So 5A, B, and C. How about I'll do B, and that'll show you how to do A and C. So from x equals 10 seconds to x equals 25 seconds. Okay. So B, x equals 10 seconds to x equals 25 seconds. Okay, so delta x is automatically 25 minus 10, which is 15 seconds, right? Delta y, change in y. So we're going from 10 to 25. Let's see. From 10 to 25, sorry, this is the best I can do. So the y values are going from 75, 30 to 75. Okay, so again, we're going from 10 to 25. So delta x is 25 minus 10 is 15. Delta y, you're going from 30 to 75. So let me put the book down. So 75 minus 30, which is 45 feet. And then give m, which is delta y divided by delta x, which is 45 feet divided by 15 seconds. So that's 3 feet per second. So we could use that as a speed. The speed is 3 feet per second. Okay. All right, so that's how you do that type of problem. And let's see. I believe 7 and 9 are very similar. 7, specify delta x and delta y in each of the following intervals. Okay, so pretty much the same thing. So there's the picture. Okay, so it works the same. How about I do 9 for you, since it's a negative slope, looks like. Okay, so I'll do 9 for you. Let's see. The following straight line graph summarizes data for world cigarette production over the years 1990 to 1993. Specify delta T and delta N for the period. Include units with each answer. Okay, so you have T versus N. All right, so 1990, 5,419 trillions, and 1993, and let's see, 5.300. Okay, so let me write that down. The book's getting heavy. So 9. The ordered pairs are 1990 and 5.419. in 1993, 5.300. So this is t, and this is n. That's sort of like x and y. Okay, so if you look at the graph, t for time, which makes sense, that's the x-axis, and n for the y-axis. So instead of delta x, we want delta t. That's easy. So 1993 minus 1990, which is 3 years. Delta t is negative 5.300 minus 5.419. Punch it in the calculator. It's negative 0.119. And the units are trillions of cigarettes. Yes, trillions of cigarettes. I'll just abbreviate with cig. Yes. Okay. And that's all they asked for in that one. Okay. Okay, number 11. Okay, sorry, I can't write this for you, so you have to listen to me. Now, if we were meeting on campus, okay, in the classroom, right, in the middle, I would project this on the screen, and then I still have whiteboards to my left and right, and I can write it down. Okay, the way we have it now, I'm not going to be able to, so sorry. You'll have to just listen to what I say and write it down. Okay, but for 11, the slopes of 4 lines are indicating the figure. List the slopes M1, M2, M3, and M4 in order of increasing value. Increasing value means go from negative to positive. Okay, so let's see. Looks like there's only one that has a negative slope, right? That would be M3. So the smallest number is M3 because it's the only negative. Okay, so the answer for 11 is M3 first. And then there's a line with a slope of 0. Can you see which one has a slope of 0? M2. Okay. And then let's see, you have M1 and M4, which are both positive. Which one is the larger positive value between M1 and M4? M1, it's steeper. Right? So the next will be M4, and then finally M1. Okay, so I'll say it again in order. Sorry, I can't write it down. But in increasing value, you've got M3, because it's negative, then M2, because it's 0, and then M4, which is positive, and then M1, which is more positive. Okay, so repeat, M3, M2, M4, and M1 for problem 11. Okay. Okay, 13, I think you can figure out. I'll just talk about it. They asked if the 3 points are collinear. Collinear means they lie in the same straight line. Okay. So I wasn't going to do it, but let me just talk about it quickly. Okay. So suppose I just randomly put down, paper's curling on me a little bit. So what if I put down just 3 points like this? A, B, C. Okay. How do I know if they form a straight line as opposed to a triangle like A, B, C? Right? Well, if you have a triangle, right, these 3 slopes would be different. But if I have a straight line, then it doesn't matter if I find a slope from A to B or B to C or A to C, they would all be the same. Correct? They all have the same slope. So the idea behind problem 13, so I wasn't going to do it, but I'll just talk about it. Okay. It says, check whether the slope of segment AB equals the slope of segment BC. Okay, so find the slope between A and B. Use the formula y2 minus y1 divided by x2 minus x1, right? use the same formula from B to C and see if we get the same thing. Okay? So if we get the same thing, they're collinear. If you don't get the same thing, then they're different slopes. That means you must have a triangle. You must have something that looks like this. Okay? So that's all. That's what's happening with that one. Okay, then let's see, 15, A and B. They give you a point and a slope. Once in a while, this thing turns yellow on me. I don't know why. And write your final answer in the form y equals mx plus b. Okay, so 15a and b. B looks harder because of the fractions. So I'll do b, you do a. So 15b, don't worry if you can't see it yet. I have to write it down before I get to it. 15b, the slope is 1/3. And the point is -6, -2/3. So write the equation on the line. So I will use the point slope form. Y minus y1 equals m times x minus x1. This is the point slope form. Okay. Now I'm going to hasten to add this. Okay. For these kind of problems, you need to do it this way. A lot of you maybe have been trained to do it without this. Maybe you were used to going y equals mx plus b, plugging in and doing it that way. Okay. Can't do it for me. I'm not going to accept it. Okay. I want you to know the point slope form. Okay. So if you've been doing it this way, fine. You need to know the point slope form though. Okay. I think a lot of it was maybe when you learned it before, perhaps in high school, maybe you didn't want to learn this because it looked harder. So you said, I'm just going to do this. Okay. Yes, there is a way to do it by just doing this. I'm not going to let you do that. I have to see this. So if I don't see this, I'm not going to give you credit for it. Okay. So this is x1, y1. That's the slope. Okay. So y minus y1, y minus a -2/3 equals m 1/3 times x minus x1, x minus a -6. So here's y minus y1 equals m times x minus x1. So just plug everything in. Let me raise it up so you can see it better. Okay, so x1, y1, m. Put this on your cheat sheet if you wish. All right, then just clean it up. Y plus 2/3 equals 1/3 parentheses x plus 6. Okay. Subtract 2/3. Subtract 2/3. So y equals 1/3 x plus 2 minus 2/3. Okay, 2 is like 2 over 1. Common denominator is 3, so times 3 times 3. So 2 times 3 is 6. 6 minus 2 is 4. Y equals, whoops. Y equals 1/3 x plus 4/3. Final answer. Okay, so that's how to do that one. All right. All right. Now, what if I am given just 2 points? So 17a, b, and c. Now, if you just give me 2 points, I should be able to come up with the equation of the line, right? I mean, 2 points, that means like this, right? I just have 2 dots. 1 dot there, 1 dot there. I should be able to connect them and come up with a line. Right? So how do I find the equation of the line? Okay, so 17a, b, and c. Which one looks the hardest? How about I do c? Looks like the most number of negatives. Okay, well, I can find the slope. And then once I find the slope, I work it out just like problem 15. Okay, so 17c, I'll do c, you do a and b. Okay. So 17c, you've got -3, -2. line 4, -1. Find the equation on a line that goes through those 2 points. Okay, so first I need to find the slope. Okay, so x1, y1, x2, y2. So -1 minus a -2 divided by 4 minus a -3. So that's like -1 plus 2, which is 1. 4 plus 3, which is 7. So the slope is 1/7. And again, let me raise it up. But I can't hold it forever. So I have to write again. All right, now notice this problem is exactly the same as the previous one. Okay. So I can pick either point as my x1, y1. Why don't I just pick this since I've already designated that? Okay, so throw it into the point slope form. So y minus y1, y minus a -2 equals m times x minus a -3. This is y minus y1 equals m times x minus x1. And once again, looks like I get some pretty bad fractions, but got to go with what they give me. Okay, so let's clean it up. Y plus 2, double negative, 1/7 x plus, whoops, x plus 3, my bad. Okay, distribute. Y plus 2 equals 1/7 x plus 3/7. Very awkward numbers. Subtract 2. 2 is like 2/1. Common denominator 7. So multiply this by 7, multiply this by 7. So I end up with y equals 1/7 x plus, so let's see, 3 minus 14. 3 minus 14 is a -11. I guess I should have just put negative, sorry. Minus 11/7. This is a minus sign. So y equals 1/7 x minus 11/7. Final answer. Okay, now let me raise this up again. Hopefully it looks better on the video. You can look at the video. Okay. Okay, so that takes care of that kind of problem. '19, pretty straightforward. Write the equation of the vertical line and the horizontal line passing through the given point. -3, 4. So vertical line is just x equals a constant. X equals something. And paper starting to curl on me. Vertical line, x equals 3. Can you guess the horizontal line? Y equals 4. So, show you back the page for that. Page 48. Horizontal line, y equals something. Vertical line, x equals something. There we go. Vertical line, horizontal line. Okay. Okay, what time is it? 11:50? Okay, we got time. '23 should be very easy. Find the equation in line with a given slope and y-intercept. They already give you the m and the b. So just write it down. Okay, so slope, C23 there. Slope, I'm going to write M. Y-intercept, I'm going to write B. You've heard of that before, no doubt. Okay. So A, M is 4. Oops, sorry, negative 4. M is negative 4. B is 7. Write the equation. Y equals mx plus b, so y equals negative 4x plus 7. Done. That's all there is to it. Sometimes I'll say it's so easy, it's hard. Okay, so people trip over it because it's so easy and you think you have to do more work. No, that's all there is to it. Just put the m, put the b, y equals mx plus b, finish. Okay. That was a little bit too easy. Okay, so how do I do some of this stuff? Okay, 25. A and B are very similar. Just do the point slope form. They give you the point, negative 3, negative 1 for A, 5 halves 0 for B, and a slope, 4 or 1 half. That's something we've done before, right? You throw it into y minus y1 equals m times x minus x1. Okay? So for A and B, that's what you do. Okay, so let me do something a little bit different. C, x-intercept 6, y-intercept 5. I'll do 25C for you. Okay, remember, x-intercept means y equals 0. Y-intercept means x equals 0. That's the way you want to do this one. Okay, so you have it. Find the slope. 5 minus 0 divided by 0 minus 6, which is negative 5, 6. The b is 5. So y equals mx plus b. Y equals negative 5, 6x plus 5. Y-intercept, same as b, it's 5. Okay. So 25D and E, they give you a point and a slope. Here they give you 2 points. Okay, so that's something we've done before. I'll do E for you. So that's a point and slope. So if I do E, you should be able to do D because it's similar. So 1, 2, and 2, 6. 25E, passing through 1, 2, and 2, 6. Okay, so there's a line that passes through 1, 2, and 2, 6. Sorry, paper tends to curl on me, so I have to stop and uncurl it. Find the equation of a line that goes through those 2 points. So find the slope. 6 minus 2 over 2 minus 1. Y2 minus y1 divided by x2 minus x1. That's 4 over 1, which is 4. And then throw it into the point slope form. Here's x1, y1. So y minus y1 equals m times x minus x1. Okay, clean it up. Add 2, add 2. Y equals 4x minus 4 plus 2, or y equals 4x minus 2, final answer. Okay. Problem's finished, but I'll dig a little deeper. 1, 2. What do you get when you plug in 1? 4 times 1 is 4. 4 minus 2 is 2. 2, 6. What do you get when you plug in 2? 4 times 2 is 8. 8 minus 2 is 6. Okay. So if you have the right answer, that should be the case, that this point works, This point also works. Okay. Okay, let's see. Then how about I'll do 29 for you, and then maybe we'll break shortly. Find the x and y intercepts of the line, and find the area and the perimeter of the triangle formed by the line and the axes. Find the area and the perimeter. How do you do that? Okay, so A and B, they look almost the same. How about I'll do B because there's a negative? So if I do B, you guys can do A. Okay, so 3x minus 5y equals 15. All right, so let's find the intercepts. Plug in x is 0, figure out the y. Plug in y equals 0, figure out the x. If I put a 0 here, 3 times 0 is 0, right? So you pretend it's not there. Negative 5y equals 15. Divide by negative 5. Negative 3. Then I plug in y equals 0. So negative 5 times 0 is 0, so forget about it. It becomes 3x equals 15. If 3x equals 15, divide by 3, 5. Okay. So let's do a quick graph of that. See what we got. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. 0, negative 3 is here. 5, 0 is here. There's the graph. Okay. And now they ask for the area and the perimeter of the triangle formed by the line and the axes. Okay, so you see this triangle here, right? Find the perimeter and the area. All right, so let's work on perimeter. Well, this is a right triangle. This is certainly 3. This is 5. This is a hypotenuse, C. So I'll use the Pythagorean theorem. 3 squared plus 5 squared equals C squared. Maybe I don't want to use greens that much because it's hard to see. Nine plus 25 equals C squared. 34 equals C squared. Take the square root. C equals radical 34. Okay, so this is now radical 34. Perimeter, just add them all up. 3 plus 5 plus radical 34, which is 8 plus radical 34. Final answer. And just leave it like that. If it doesn't ask for a decimal approximation, don't just leave it like that. And it asks for area. Well, do we call the area of a triangle? 1/2 base times height. So 1/2 of 3 times 5 is 15 over 2. You can leave it as 15 over 2, or if you like 7.5, that's also okay. So there we go. All right, so that's about it. Looks like a good time to break. Let me check the chat. Is there a question here? All right, so I got that for a little bit later. Okay, so let's go ahead and break now. I'll stop the share. It's about 11:57 now. Let's start up again at about 12:10. Okay, so break until 12:10, and I'll put that in the chat too. Until 12:10-ish. All right, so we'll break. I'll disappear also. Okay, folks, let's go ahead and start up again. So I was almost done with 1.6. So I'll do some more 1.6, get started with 1.7, and then give you some problems to do, and then that'll be it for today. Okay. Again, you're welcome to put questions in the chat, and if you wish, I can't see it at the same time, but perhaps Star can help me since she's our embedded tutor and help me out with this. Okay, so. All right, how do you do stuff like 31? Determine whether each pair of lines is parallel, perpendicular, or neither. Okay, so what you're going to do is find the slopes in each case. Let's look at the rule for that. Page 50. Number 1, lines are parallel if and only if M1 equals M2. So if you find they have the same slope, the lines are parallel. 2, the lines are perpendicular if and only if M1 equals -1 divided by M2. They are negative reciprocals of each other. And I'll show you some examples of that. In any other case, then the answer is neither parallel nor perpendicular. Okay, so how do you do that? Okay, so 31. So notice they give you the equations of two lines. That's one line, that's another line. One line, another line, one line, and so on. Okay, so you have to come up with a slope and then use the rule that I just showed you to determine parallel, perpendicular, or neither. Okay. 31A. (3x minus 4y equals 12) and 4x minus 3y equals 12. Okay, now you don't have to graph these, but if you were to graph it, and if you were to graph this, okay, are they going to be parallel like that? Or are they going to be perpendicular like that? Or maybe neither. Maybe they touch, but not at 90 degrees. Something like that. So in order to determine it, I need to find the slope. Now, if you give it to me like this, the way to find the slope is to make it look like slope-intercept form. Solve for y. Right? So 3x minus 4y equals 12. Make it look like y equals mx plus b. So how about subtract 3x? Okay. And I mentioned before, this is my way of saying what? Subtract 3x on both sides, right? So negative 4y equals negative 3x plus 12. Subtract 3x, subtract 3x. And now how do I isolate the y? Divide by negative 4. So I get negative 3 divided by negative 4 is positive 3/4 x. And then 12 divided by negative 4 is 3. So 3/4 x minus 3. All right. So this equation now looks like this. So what's the slope? 3/4. So M1 is 3/4. Okay, so now I find M2. So what's the slope of this one? 4x minus 3y equals 12. Did I write that right? Yeah, that's right. Okay. So same thing. Solve for y. Now let me raise it up again for focusing purposes. Okay, so isolate the y So move the 4x over, right? Subtract it. Negative 3y equals negative 4x plus 12. Divide by negative 3. So that cancels out. Y equals. Okay, negative 4 divided by negative 3 is a positive 4/3 x. 12 divided by negative 3 is minus 4. Okay, so I force this to look like y equals mx plus b. I force this to look like y equals mx plus b. Okay, so now what's the slope of this line? 4/3. And now it's a little bit tricky. The paper's curling on me again, sorry. I'm trying to uncurl it from time to time. All right, so look at that and that. 3/4, 4/3. Are they equal? No, they're not. Are they negative reciprocals? They are not negative reciprocals. They're just reciprocals. The reciprocal of 3/4 is 4/3. In order to say that they're perpendicular, this one would have to be, say, negative 4/3, right? So 3/4 is the reciprocal of 4/3, but not the negative reciprocal. So the answer to this one is neither. Okay. Neither parallel nor perpendicular. They're not equal. They're not negative reciprocals of each other. Okay. All right, so that's how that one goes. 31b. B should be much easier. That already looks like y equals mx plus b. That already looks like y equals mx plus b, right? So what's the slope of this first one? 5. What's the slope of this one? 5. Same slope. So what's our conclusion? They're parallel. Okay, so 31b, put down parallel. Okay, C I wasn't going to do. You have to work out C just like I did A, right? You have to force that to look like y equals mx plus b. Force this to look like y equals mx plus b. So do C like A, and then you can get it. Okay, I will do D because that's easy. It already looks like the way it's supposed to be. I can raise the book up a little bit. Yeah. Okay, D. What's the slope of this line? Negative 2/3. Slope of this one? 3/2, 3/2. Are they negative reciprocals? Yes, they're negative reciprocals. The negative reciprocal of negative 2/3 means you flip it and change the sign. You get 3/2. So the answer to D, as in dog, is perpendicular. Okay. So that's going back to this over here again. Number 2, the lines are perpendicular if and only if M1 equals negative 1 divided by M2, or they are negative reciprocals. So they are negative reciprocals of each other. Okay. If you flip this one and change the sign, you get 3/2. Okay, so I did A, B, and D. You just do C on your own. All right. And finally, 33 and 35, and then that's it. I'll get started with the next section a little bit. Let's see, we had to go up to 35, right? Find the equation in line that is as described. 33, parallel, blah, 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 passes through a point. 35, perpendicular to blah, 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 passes through a point. Okay, so 35 is harder. Okay. For 33, it's easier because for parallel, you just use the same slope as this one. I'll do the harder problem, 35, perpendicular to whatever and passes through a given point. Okay, so I'll do 35 for you. I will abbreviate perpendicular with this. Okay. So perpendicular, you just do an upside down T. Some of you might recall something like that in high school geometry, or perpendicular. So perpendicular to what? 4y minus 3x equals 1. And it passes through the point 4, 0. Okay, so first I have to find the slope of this line. Solve for y. Move that over. Four y equals 3x plus 1. How do you isolate the y? Divide 4. Okay, so to find the slope, make the equation look like y equals mx plus b. There it is. So what's my slope? 3/4. Okay, now pretend I was doing problem 33. You would just keep the 3/4. Okay, they got different numbers. So 33, it says parallel, right? So you do the same stuff as I did for 35. Once you get blah, 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 y equals mx plus b, read out the slope. Keep that slope and use that point because it says parallel. That's the easier problem. Perpendicular is a little bit harder. So for perpendicular, I need the negative reciprocal. What is the negative reciprocal of 3/4? That means flip it, change the sign. Negative 4/3. Okay. All right, so I use this slope. I use this point. Throw it into the point slope form. Y minus y1 equals m times x minus x1. Okay, so negative 4/3 goes there. And we are given the point 4, 0. That's x1, y1, right? x1, y1. So 4 goes here, 0 goes here. Oh, I like subtracting 0, right? When you subtract 0, you're not really doing anything. So y minus 0 equals m, negative 4/3, parentheses, x minus 4. Okay, let me raise it up a little bit. Oh, look at the left-hand side. Just y. So it's already done. You already have y equals mx plus b. So I just multiply that stuff out, right? So y minus 0 is y. So negative 4/3 x plus 16/3. And that's pretty much about it. Okay. Okay, so again, the technique. First, I find the slope of this line. I found it to be 3/4. But they asked for a line perpendicular to that. So I'd flip it and change the sign, negative 4/3. For problem 33, it said parallel. So whatever you get at this step, just keep it. Then I do the point slope form. And there we go. All right, I am done with the section, folks. So let me see, I do see something in the chat. So I've knocked this off. I can begin 1.7. Let's look at our schedule. 1.7 was supposed to start tomorrow. Okay, so I can sneak in some of it now. Right, so I'll do some of it, and then I'll stop and let you do an in-class assignment. Okay, let me quickly check the chat. Let's see. Okay, I think we're good. Okay, so 1.7. Okay, we're going to learn something about symmetry with graphs, and then also introduce something about circles. I believe you've seen some circles in intermediate algebra. So let's see what that's all about. Okay. So 1.7 in key items, and I'll show you the pages you need. Now, why don't I just get that out of the way? So 1.7. Remember, we're not having a test on just chapter 1. The test is on chapters 1 and 2. So when we have our first test, which is Thursday, February the 4th, it's chapters 1 and 2. Now, I may very well go ahead and get started with some of chapter 3, okay, but none of chapter 3 will be on a test on Thursday 2-4. It'll just be a chapter 1 and 2 test. Okay, so let's see, we have 1 to 25 and 41 to 49. Okay, so let me show that to you again for the benefit of those of you that aren't getting the text. I can find it here. Okay. Oh, it's all on one page. Okay, that helps. I don't know why this is yellow. So page 71, 1 to 25. Okay. So there's 1 to about 6, I guess. 7, 9 through 25. Okay, and then let's see, 41 to 49. Yeah, I got to show you. Yeah, 41 to 49. You can see it there. Let me raise it up a little bit. Yeah. Okay. So I'll do some of this. What time is it? About 12:30. I'll do a little bit, then I'll give you some problems to do, and then we'll probably end a little early. Okay. Okay. So we're talking about symmetry now. Something about symmetry. Page 59. Okay, so again, I'll show you the key points here. Okay, so this is so-called symmetry about the x-axis. And for those of you who don't plan on getting a book, and there's all of this that you might want to read. You might say, do I have to read it? Well, if you know what's going on, you don't have to read it. If you don't know what's going on, then I would say read it. Okay, then symmetry about the y-axis, number 2. And there's a description. And then symmetry about the origin, figure 7. And there's a description on that. Okay, got to put the book down because it's heavy. Okay. So the idea about symmetry is this. Okay. For x and y axes, I think it's a little bit easier to understand. Okay. Symmetry about the x-axis. So imagine if you take the top part, right, and just kind of put a mirror right there, you get the mirror image, right? The reflection of the top is the bottom and vice versa. So that's called symmetry about the x-axis. Okay. Symmetry about the y-axis. Sorry, I know it's a little bit blurred, but hopefully you get the idea still. Okay, so if I draw a line like so, or put a mirror about the y-axis, right? Then this part reflects over here. Okay. Symmetry about the origin is a little bit tougher, okay? But it's like you go across the origin. So if I take this graph that looks like this, if I take any point and reflect across the origin, you get a corresponding point here. But let's say I take a point over here, I reflect across the origin, it comes over here. So that's called symmetry about the origin. Okay, so you can have x-axis symmetry, okay, which means if you put a mirror on the x-axis, right, the reflection of the top is the bottom and vice versa. You can have y-axis symmetry like that. So if I put a mirror on the y-axis, then the left and right are reflections of each other. A little bit difficult, more difficult concept is reflection about the origin. So it goes like so. Now, what's all this talking about? I can try to summarize it. If you have a point x comma y, you also have x comma negative y, which means if I replace y with negative y, I also get a point on the graph. So let's say if this is the point 3, 3, this is the point 3, negative 3. This is 1, 1. This is 1, negative 1. Okay. For this kind of symmetry, y-axis symmetry, notice you have 2, 4, negative 2, 4. xy, negative xy. So that means if I replace x with negative x, I get an equivalent equation. Then for origin symmetry, here's x comma y. Here's negative x, negative y. That means if you replace x with negative x and also y with negative y, you get an equivalent expression as the original. So let's say this is the point, I don't know, 8 comma 2. This would be negative 8 comma negative 2. Okay, now the first problems they give us are just examples of trying to draw these things. Page 60. All right, now you're not supposed to see this yet, but I know it's too late. Okay, so complete the graph with y-axis symmetry, x-axis symmetry, origin symmetry. Okay, sorry, I can't read it up anymore. But if I want y-axis symmetry, put a mirror right there, and you would get a branch like so. So there's the answer to A. Complete the graph with y-axis symmetry. Okay, let's see. X-axis symmetry. Okay. So if I reflect across the x-axis like that, I'll get something up over here. That's this one. Okay. Origin symmetry. A little bit harder. So if I take this point here, right, reflect across the origin, I get a dot over here somewhere. If I take this point here, reflect across the origin, you have something here. So you would have this graph curved down like so. That's what you would have. Okay. All right. So let me try to show you how some of these would work. Okay. The endpoints of a line segment AB are given. Sketch a reflection of AB about the x-axis, y-axis, and the origin. Okay, so 1, 3, and 5. And so let's see. How about I'll do number 3? That looks the hardest. It's got more negatives. And then hopefully you can do 1 and 5. Okay. So 1.7, page 71. Number 3. The point A is negative 2, negative 3. And 2, negative 1. All right. One, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, negative 2, negative 3, 1, 2, 1, 2, 3. That's over here, right? 2, negative 1. 1, 2, negative 1. Okay, so this might be a little bit tricky. Okay, sketch the reflection about the x-axis. Reflect about the x-axis. That means I'm going like this. Now, if you have a hard time seeing the whole thing, you don't have to do the whole thing. Just break it into pieces. Just take this piece right here, right? So if I take this and reflect about the x-axis, this one was, let's see, negative 2, negative 3. That would be up here. Negative 2, 3. Do you agree with that? If all you saw was just this bottom part, right, reflect across the x-axis, put a mirror right here, then we get this piece. Okay. Now I do the same thing for this little part here. So pretend all I see is this. So you don't have to see the whole thing at once, just break it in pieces. What's the reflection of this little piece across the x-axis? Well, this point would come down here, right? That's part A. So this is the reflection across the x-axis. Maybe I should have put different colors. Yeah, so the answer is the one that is sort of in red. And if you can't see the whole thing because it passes by, just split it into two pieces, right? So I had this bottom part, so the reflection would be like that. And then I had that top part, the reflection would be like so. Okay, so that's A. Okay, and then B, they want the same thing, except the reflection about the y-axis. So start with the same picture. Okay, start with the same points. Let's see, it was negative 2, negative 3, negative 2, negative 3 is like there. Well, you know what? This is supposed to be 2, negative 1, right? Oh, I goofed. 2, negative 1. That's supposed to be here. Sorry about that. Okay, so I botched this one up. I have to redo this one. Sorry. I had it going up to here, but it's only supposed to be here. Well, let me do this while I'm at it. Okay, this time says reflect about the y-axis. Reflect about the y-axis. So this point would come over here. This point would come over here. So it should be like so. And you can kind of see the reflection of one as the other. Okay, let me go back and fix A. Actually, it's going to be much easier. The graph is going to be much easier, turns out. Let's see, it's supposed to be negative 2, negative 3, and 2, negative 1. Negative 2, negative 3, 2, negative 1 is like that. Yeah, that's much easier because I don't have to split it into two parts. Okay. So this one would still come up to here. 1, 2, 3, 1, 2, 3. But let's see, this one was 1 unit below, so this would be 1 unit up. And I don't even have to cross the x-axis. So that actually makes a much easier picture. So this should be A. Okay, and then C, that's going to be a little bit harder because maybe we're not used to reflecting about the origin. I will take the approach of switching the X and Y coordinates. I'll show you how to do that. All right, so this is reflection about the X-axis. This is reflection about the Y-axis. And this is reflection about the origin. Okay, so let me start off with my points again. -2, -3, -2, -3, and 2, -1. Okay, so I'm going to take advantage of this picture. I can find it. Back on page 59. See where it says x, y, and -x, -y? So you replace x by -x and y with -y to reflect across the origin. So what does that mean over here? Change the sign of both of these, and you would have 2, 3. Okay, so 1, 2, 1, 2, 3. So the reflection of -2, -3 across the origin is 2, 3. And same thing here. Change each of these signs. You would have -2, 1. -2, 1 is over here. So one more time. Change both of these signs. -2, -3, 2, 3. Change both of these signs. -2, 1. So you can see the reflection of this point across the origin is this point. Same distance. Reflection of this point is this point. Okay, and then I just connect it, and then we're done. Okay. So that's about it for that one. All right. Seven. I'll do that one, then I'll stop. Complete the given graph to obtain graphs with each of the basic symmetries. Okay. Fortunately, because of the way the graph is, I can do it all on just one graph. Okay. So I'll show you how that works. And then I'll be done. So after I finish 7, I'll check the chat. Some of you have something in the chat. I'll get that out of the way, and then we're finished. Okay. So it starts off with that. Yeah, I could put the whole thing in one graph. Okay. All right, symmetry with respect to the y-axis. We go like this. Pick a different color here. Y-axis symmetry. How about x-axis symmetry? Can you see what would happen? It would bounce over to here. Can you guess what would happen for origin symmetry? There's only one quadrant I haven't used, right? So this would bounce over here. This would bounce over here. It would end up looking like this. Get all my different colors here. Origin symmetry. Okay, so the green, I'm not sure if you can see the green. I'll raise it up. Okay, so the black is the given function. The green is y-axis symmetry. The red is x-axis symmetry, and the blue is origin symmetry. So there we go. All right, that's it, folks. I'm done. Let me check the chat real quickly. Shouldn't be crossing exercises. Right. Okay. Yeah, I goofed on that. Okay, I think we're caught up. All right, folks. So I'll give you something to do right now. As usual, send it to me by private chat so that somebody else can't just, copy what you have. Okay, so go back to where we were. Over here. So I was supposed to start 1.7 tomorrow. I already stuck in a little bit of it, so I think we're good. So a little bit ahead. Okay, let's go back and do some slopes. Okay, so I'll hold up the book. Okay, so I believe I did 1B. So I want you to do on page 52, 1A and 1C, please. Just find the slope. You don't have to sketch it. Okay, so 1A and 1C. If you have the book, then just use it. If you don't have the book, maybe take a picture on your cell phone. The book is very heavy. I can't hold it that long. Okay, so 1A, just find the slope. So A is -3, 2, and 1, -6. Throw it into the formula. You don't have to show me your work, just give me the answer. And then 1C, -2, 7, and 1, 0. Again, 1A, -3, 2, 1, -6. C is -2, 7, and 1, 0. I'll hold this just for a few more seconds because I can't hold it that much longer. And when you have the answer, just type it in the chat, and then you may leave, and I'll see you tomorrow. So use the formula for slope, y2 minus y1 divided by x2 minus x1. If you have a question, you can ask Star or me. For this one, you can just type the answer. Yeah, and ordinarily, when you give me your homework, your quiz, or test, show me all your work. This one, just give me the answer, and then you can go. Okay, I'm going to put this down because it's too heavy. And I'll assume you have it. If not, then ask me, and maybe I'll just type it for you. Okay. So I'll stop the share. I will stop recording also.